So let's start with this problem yesterday. On a scale of 1 to 10, 10 being the easiest, 1 being the easiest, 10 being the hardest, where did this fall on your homework last night? Probably a 9, right? It's probably one of the harder ones you had to do on your homework, wasn't it? Okay? So let's see if we can make it through. But before we do this question, I want to ask you this. How would I solve this problem? I mean, is there any question about that? No, because you've been doing problems like this since 8th grade? Pretty positive, 8th grade, right? So we subtract 10 from both sides. 3x equals 27. Good. Divide by 3 on both sides. X equals 9, right? Guys, how is this question right here any different from this one? Isn't our goal to try to isolate the absolute value? It's not going to help the people watching the videos, but look right over here on the board. What's our first step? Isolate the absolute value. If I'm trying to isolate this, aren't I treating this like it's some sort of variable at the beginning? I got to get this all by itself. Isn't that what I'm doing with this x? Trying to get it all by itself? So in this problem right here, what do I do first? I subtract to 10. Then I have 3 times this absolute value thing that I'm trying to solve for equals 27. What do I do now? Can I tell you what some other people tried to do? Or can you tell me what some other people tried to do? Not even that. They tried to multiply the 3 in. They wanted to distribute the 3. Can you just put stuff into an absolute value? Can you just pull stuff out of an absolute value, like the 5, like you suggested? You can't do that. You take it out as a group, right? That's all you can do. So right now, we do kind of like we did over here. We subtracted the 10 first. Now we have to, if our goal is to isolate the absolute value, we have to get rid of that 3. Okay? So if I divide both sides by 3, I have 2x plus 5 equals 9. Oops, there we go. Now that my absolute value is isolated, what do I do next? Exactly. You got to have a positive and a negative, right? Whatever's inside, I have to have a positive value of it. 2x plus 5 equals 9. And then I also have to have a negative value of it. 2x plus 5 equals 9. Guys, this was confusing people yesterday. I'm not really sure how I can say it any different, so if you guys know any way I could say it different, I would love to hear your suggestions. Whatever's inside, I have to directly pull it out and write 2x plus 5. This is a plus in the problem, isn't it? Like I wrote it down correctly? Okay. What if this was a minus? Would it stay a minus right here if I'm pulling out a positive value? It would stay exactly as it was, right? If it was 2x minus 5 here, it would be 2x minus 5 here, right? And I think that's where people were getting confusing yesterday, because they think, by the way I'm saying it, that everything has to be positive that I pull out. Well, what I want is the value that I pull out to be the positive value of what's inside. And what I want is that this one for it to be the negative or the opposite value of what I had inside. Maybe is that a little bit better way to say it? You're like, I don't know, I understood it the first time. Good. Okay, good. All right. How do I solve this one right here?
Minus 5.
If I subtract 5 from both sides, I get 2x equals 4. Very good. X equals 2. What do I do over here? Okay, so yesterday we talked about the fact that there was 2 ways to do this one, right? We said we could divide both sides by a -1, or we could distribute the -1, right? So I know I told you whichever way is more comfortable for you, do it that way. And I still stand by that statement. However, knowing where we're going today, might I suggest that we all do it the same way? If you don't want to, it's not wrong. Okay? I promise it's not wrong. I'm not going to take points off for it or anything like that. But here in a second, when I show you today's lesson, I hope that you'll see why I'm suggesting this way. Fair enough? I'm going to suggest this way. What happens if I divide a -1 by a -1? Yeah. Negative divided by negative is a positive, right? So that's those signs are both positive now. 2x plus 5 equals -9. So if I subtract 5 from both sides now, I get 2x equals -14. So dividing by 2, excuse me, penguin, x equals -7. Is that all I have to do? Is that the end? I need to check it, right? Isn't that part of my solution? Part of making sure I'm solving it is actually checking it. Okay? So 2. 2 times 2, 4. Okay, good. 4 plus 5, 9. Absolute value of 9 is 9 times 3. 27 plus 10?
37.
Does 37 equal 37? Then I know for sure that this works, don't I? What about -7? 2 times -7. -14 plus 5. -9. Absolute value of -9? 9 times 3. 27 plus 10. Does 37 equal 37? Yeah. I don't have to have a shadow of a doubt whether that's right or wrong. I know it is. I just proved it to myself. Right? Now, is that it? Oh, we have to graph it, right? Okay. So here's -7. Here's 0. Here's 2. What's it look like? What's my graph look like? Say a little louder, please. Closed circle on 2 and a closed circle on -7, just like that? Perfect. Wait, I don't have to like color in between them or color on the outside?
No, ma'am.
Because what are the answers? Just 2 and just -7. Not anything else, right? Nothing else works. We just proved that, didn't we? Okay? So that's it, right? Are you feeling any more comfortable with this today than you did yesterday? Guess why? Because we did it again. Right? We're doing it again. So people complain about homework, and the only way you can get better at math is to do math. Right? Do I overload you with homework? Do I try to give you time at the end of every period to work on your homework? Yes, I do. Yes? Okay? So let's think about this in a positive way. Fair enough? So, I'm going to come back up here to the top. We're going to ignore this part over here. Okay? But I want to teach you today's lesson using this problem. If you're going to write over like what I'm going to do, I would prefer you use a different color. Okay? I have colored pencils back here if you want to come borrow a colored pencil. Because here's today's lesson. Here was yesterday's problem, right? This was yesterday's problem. Here's today's problem. How's that different? Oh, so at the very end, it's going to have the arrows on the graph, right? How is it different from here? It's not. I still subtract 10 from both sides, and I get this, except this is greater than or equal. Okay? I still divide by both sides by 3, don't I? And I still get this, except for this is greater than or equal. Right? I still pull out a positive and still pull out the negative, don't I? Except this is greater than or equal. And I still subtract 5 from both sides, except this is greater than or equal. I still divide both sides by 2, except this is greater than or equal to 2. Okay, so right here, let's see, if this was greater than or equal, then this is greater than or equal. I still divide both sides by -1, except this is... Ooh, why are you saying less than or equal?
Divide by negative and makes it
Genius. Excellent. How many of you remembered that? Okay. How many of you remember that because it says it on the board? That's okay. That's okay. Okay. Right over here. Look, number 3. Okay. We'll write them down here in a second so the people that are watching the video can get them too. Okay. But when we multiply or divide by a negative number, we have to flip the sign. Do you know why? Is that just one of those rules that people have just taught you and you just do it? So can I show you real quick? Can I show you why? All right, let's see. Let me get my blue pen back. 2 is less than 8. Is that true? If I add 5 to it, does that change anything? 7 is less than 13. Is that still true? If I subtract 4 from it, is that still true? 3 is less than 9. If I multiply anything by it, is it still the same? Like if I multiply by 2, 6 is less than 18. Is that still true? What if I multiply by -2?
That's not true.
-6 is less than -18. Nuh-uh. No, it's not. Right? What if I... So, we know that's not going to work. What if I divide both sides by a -3? -1 is less than -3. Uh-uh. No, it's not. In order to keep the inequality true, when we multiply or divide by a negative number, we have to flip that inequality sign. Now, there were people confused about this earlier. We're not flipping off the inequality sign. We're just flipping the inequality sign. There's a big difference. One will get you sent to the office. Are you okay? Okay.
Somebody actually said,
Welcome to my world. All right. So it was greater than. We divided by a -1. Now it's less than. So let me ask you this question then. Do you see why I suggested that we divide by -1 first? How much more likely are we to remember to flip this first than if we have to do it down here somewhere? A lot more likely, right? We're more likely to forget it if it's way down here. So if we do it first, we're more likely to remember our inequality sign. If you do it the other way, is it wrong? No, it's not wrong at all. You can still get the right answer. It's just further down in the problem that you have to remember to flip your inequality sign. Fair enough? I'm not going to count it wrong. I'm not going to, unless it's wrong. But if you do it the other way and you still get the right answer, there's not going to be any points off or anything like that. This is just a suggestion. That's it. Fair enough? So if this is less than or equal, then what's this one? Less than or equal to. What's this one then? Because all the steps are still the same, right? We still subtract 5, we still divide 2, we still get x is -7, but it's less than or equal to -7. So how is the graph different? We are shading. We're shading, right? I wasn't trying to shush you. I was trying to help you with the beginning of the word, okay? We're shading. So x is greater than or equal to 2. Which direction would I shade for that? That way, right? What about this one? X is less than or equal to -7. This way, okay? Now, are these open circles or closed circles? Why are they closed circles? Because they're or equal to. That's exactly right, okay? Remember, if it's less than or greater than, it's going to be an open circle. Because it would be like x is less than 2. So if we have a little, here's a 2, it would have to be not including 2 and to the left. Right? Does that make sense? And if it's less than or equal, greater than or equal, those are closed. Because we're including that particular number as part of our answer. Because it could be greater than or it could be equal to. Does that make sense? So here, all we have left to do is shade this way and shade this way. So, I have some vocabulary questions to ask you. Most of this vocabulary I think you already know, but I just want to make sure. Okay? Looking at this solution that we just found out right now, is this the intersection of two sets? Notice how this is one set of numbers, everything greater than or equal to 2. Notice how this is a second set of numbers, everything less than or equal to -7. Is this the intersection of two sets? So I see a couple people shaking their heads like no. I see a couple people looking at me like I'm crazy. Well, I am. That's okay. Okay? What if we graphed it correctly? What if these were a little different and it looked like this? Would that be the intersection of two sets? Can you tell me why it would be the intersection of two sets? Because they're connected, right? All the numbers that are in this set are also in this set, right? So tell me why these are not an intersection of two sets. They're not touching, right? Now I asked earlier, is this the intersection of two sets? They were like, yes. I said, why? I said, because they intersect. I'm like, well, we can't really use the word when we define a word. It's like, what is kleptomania? Oh, it's somebody who is a kleptomaniac. If you don't know what that means, you still don't know what a kleptomania is, right? You see what I'm saying? So be careful using words to define those same words, right? So if I'm asking if it's a set of intersection, or excuse me, an intersection of sets, we don't want to say yes because they intersect, right? I know that you know what intersect means, but we're just trying to work on developing our vocabulary. Deal? Okay. So the point that I'm trying to get across with this particular problem right here is how different are yesterday's steps from today's steps? Not really, right? Mostly until the very end. Right here when we have to make sure to flip the sign, and right here when we have to graph. Right? Other than that, they're not really different, are they? Okay? So let me do a problem from beginning to end so you can see for sure that they're the same. So let's do x minus, well that's a plus, so we'll do plus. How about 3x plus 4? What did I do on that one? So we'll do less than 8. 3x plus 4 is less than 8. So our first step is what? Isolate the absolute value. Is the absolute value isolated on one side of that sign? Yes. Yes, so it's done, right? Number 2, give me a positive and give me a negative. Okay? Now, I have to be perfectly honest. There's some things that I'm picky about and there's some things that I'm not. Okay? I saw this earlier. Somebody did this. They went negative 3x plus 4 is less than 8. And they just used this as a positive and started subtracting 4 from each side. I'm not okay with that. Because if you're doing that to this right here, it almost seems like it doesn't matter if the absolute value signs are there or not. I knew what the person was doing. They were just using that, like trying not to really waste 3 seconds of pencil lead. I get that, okay? But I would really prefer if you give me a positive, completely separate problem, give me a negative, completely separate problem. Fair enough? Okay. So, again, I do want to subtract 4. 3x is less than 4. Oh no, this is where people freak out. Why? They don't know what to do. What do we do now? What do we do? Watch what we do. 4/3, just leave it alone. I know it's a fraction. Fractions are our friends. We've discussed this before, yes? They're not the friends that you hang out with all the time. They're the friends you put up with. No names. No names. Rude. What about here? Divided by -1. What do I forget? It's not less than anymore. It's going to be a greater than sign, isn't it? So when I subtract 4 from both sides, I get 3x is greater than -12. And when I divide both sides by 3, Yet x is greater than negative 4. So here's negative 4, here's 0, here's 4/3. What goes where? An open circle on negative 4. Open because that is just greater than, right? Which way am I going to shade when it's time to shade? To the right. So I'm just going to give myself a little arrow to remind myself which way to shade. Open circle on 4/3 because again that's just less than. It's not less than or equal, just less than. And because it's less than, I'm going to shade to the left. So where am I going to end up shading? In between, which means it is called intersection of sets, isn't it? Questions? How confident are you feeling? Give me a show with your hands. Okay, some good signs. Any questions about this? I'd like to give you the rest of the period to work, if that's all right with you. Good question. Let's go ahead and write those down just so we have them. Okay. So, number 1, go ahead and put these in your warm-up section. In fact, so we have them to refer back to in your warm-up section. First section in your notebook. Put today's date, 9/7/16. Rule number 1, or first step, not rule. First step. Isolate the absolute value. What's our second step? Give me a positive and a negative. Good. Number 3, solve. What all goes into solving, though? Isolating your x and checking it, right? Now, if we're talking specifically about an inequality, what do we want to remind ourselves? If we divide by -1, flip your inequality. And what's our fourth step? Graph. Okay. Remember, just like our conversation earlier, I didn't put check in here anywhere, did I? Because we're implying that solving it is checking it. Once we solve it, we immediately put it back in to make sure we have truly solved it. Okay? Any questions? Thank you for the reminder. All right, you have the rest of the period to work on these. So while I'm in the room, ask me questions if you need to, all that kind of stuff, okay?